I'd like in this video to explain a few electrical terms. The first one is what's called conventional current as compared with electron flow. When electricity was first discovered, or its nature as to the fact that we had two types of charge, one being positive and the other one negative, it was also known that electricity would flow. What they didn't know was what was actually moving. And what was actually moving, of course, was later discovered to be electrons. But the convention was developed that electricity flowed from positive to negative. And in the meantime, what happened was there was a development of a whole series of laws related to the flow of electricity, in particular with regard to electromagnetism. It was realised that associated with an electric current was a magnetic field. And we had, following that, a series of inventions. We had the invention of an electric generator here to make a current. We had here an electric motor. You can see that spinning. A whole series of laws relating to the flow of electricity through the generator and through the motor were developed to help explain and control what was happening. So we are stuck with those laws. So we have those two types of electricity: electron flow and conventional current. So whenever we're speaking about the electromagnetism, generators and motors, we are talking about conventional current, positive charge flowing to negative charge. Otherwise, we are speaking about electron flow, and this is how, in various circumstances, you can tell which direction or which type of current you're talking about. Now, the other term or terms which I want to talk about are AC and DC. We see AC and DC written on a device like this, which of course is our power pack. DC stands for direct current. Now, a direct current is a current which flows in one direction. And a direct current is very obvious in the case of a cell, commonly referred to as a battery. When we make a connection in our electrical devices between this end and this end, we have a flow of electrons in this direction, from the negative terminal down here to the positive terminal there. When we put these cells together like this, we have what's called a battery. Now, the term battery really applies to a series of cells, in this particular case, collected together. We can have batteries of all sorts of things. The normal use of the term would be that this is a battery, and so on. But if you have studied chemistry, you might be familiar with the concept of a chemical cell. So this is in fact a cell. We've got 4 cells here that really make up one battery. Going back to our power pack, when we have a look at the DC here, which is direct current, the other term that we've got down here is AC. AC stands for alternating current. An alternating current is one which is going backwards and forwards. If I was to look at an electron here in this wire, the electron would be going like this, many times per second, vibrating, if you like. Another word that is used is oscillating. This power pack actually uses an alternating current, and that alternating current comes from a generator, which either in Australia comes from somewhere near a dam or somewhere near a coal-fired power plant. So that AC comes to here, and inside our power pack we have what's called a rectifier, and that rectifier changes the current which is going like this to a current which is going like this, 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 this. And you can see that illustrated here on this little symbol. So it's not a uniform direct current. We do get a uniform direct current coming from batteries, and this is why sometimes we would use batteries instead of a power pack like this. So those are a few terms that we've hopefully got a better understanding of. First of all, the difference between conventional and electron flow when it comes to current, the difference between a AC, alternating current, and direct current, and the difference between a cell and a battery.